hosted. You know more about it than I do. This is
yeah. So welcome everybody. By the way, I'm impressed on like how many people we could get in here in like such a short notice. When did we start announcing this?
Like 2 days ago, something like that. Yeah,
that's awesome. I like doing this. I was just like doing this, like, hey, let's cut it really close and see how many people we could get in at the very last minute. And we've been doing really well.
Yeah,
I think it's a lot of fun.
People are still trickling in, so that's awesome as well.
Excellent. Yeah. All right. Well, yeah, let's talk a little bit about GraalVM. Graal. So
Graal the Magnificent.
Graal the Magnificent. So this is a little bit about from my presentation for Graal the Magnificent. So let me start off here with a little bit of an introduction as to already the questions are coming. I love the questions are coming in. Hey Dan, really quick, how does it cost money? Maybe. I like the question though, because it's just like, hey, this is Oracle, right? Yes. Does it cost money? Maybe. So I love that. All right. So universal virtual machine. I'll address the perhaps money issue behind it. Efficient execution with something called a just-in-time compiler. Polyglot, multiple languages. So I'll show you that. And so you could do JavaScript, you could do Python, you could do Ruby with it. Some languages are better than others as far as implementation goes. But I think it opens ourselves up to something really cool. Native compilation, we'll talk about that. Embedded integration with languages, so I could say run JavaScript within Java. I could run Ruby within JavaScript, and so they could all talk to one another. Pretty cool too. We're in release 20.1.0. They still have a funky way to name versions. This is from Oracle, so you should expect some funky version numbers along the way as well. So Community Edition and Enterprise Edition. So I think this is where Matt's question will come in. Community Edition is free. I suspect it will always be free, although I have a little bit of a hesitancy when it comes to stuff provided by Oracle. So I checked the licenses as well. They are open source licenses for the Community Edition, so you should just be good to go. So free development environment, production use, GitHub accessible, pre-built for Linux, Mac OS X, and Windows. Yeah. Now there's the Enterprise Edition, which is the for-pay. You can use it, while trying things out. But once you move over to production, then I think that's where the wallet or the checkbook or the credit card will come in. The thing that has me weirded out is this first bullet point here, and they bill it as, hey, we got additional performance if you wish to pay for it. And I'm like, it's kind of a weird tactic. I don't know specifically what that means, but it sounds like a weird tactic. Listen, buddy, you're not going to get any performance until you pay us money. It seems like the performance should already be in the Community Edition, but that's the way they're going about it. Security, scalable, free evaluation, but then for pay commercial. You could take a look more at the graalvm.org downloads. So Polyglot Support. So you have a wide range of languages that can talk to one another. AIX, yeah, I don't know if I can help you with that one, but that one threw me off a little bit. But Polyglot Support, Java, JavaScript, of course, anything JVM wise. So Kotlin, Scala, Clojure are all part of it. Ruby, R, Rust through LLVM. So we could use, oh shoot, you know what? I'm so sorry, Groovy programmers. Oh, I can't edit this slide. Yeah, absolutely. Sorry about that. Yeah. All the Groovy programmers are just like, why'd you forget about us? No, Groovy is absolutely in there. Yeah, I love you, Groovyist. All right, so yes, Python, Swift, Fortran, LLVM, and then C and C++ through LLVM. So you can run this all within the JVM. So you get this pretty neat polyglot support. So this chart is often used. This shows the layers on how GraalVM works. So we have Java, Scala, of course, Groovy. Sorry, Groovyist. I'll do better next time. But they all compile through the Graal compiler and then work with the Java 9 plus JVM CI and then which then hits the Java hotspot VM. But we have alternate languages, R for for data scientists that I was going to say data scientists that were born before 1980 will use R. No, I'm just kidding. But R and Python are the languages that data scientists use. So R is available, Python's available, JavaScript. And so depending on which layer you wish to use. So if you're thinking of using R, for example, there is a compiling layer called FastR. JavaScript will use GraalJS as the layer. Ruby will be using Truffle Ruby, and all the LLVM languages like C, C++, Rust, etc. will be using Sulong for that. Now, they all interact with something called a Truffle integration framework. And so this is kind of like for the interpretation into Java. So in the end here, if you wish to use any one of these languages, they are all running on the JVM. So that also means that whatever you wish to use here will be using the JVM. So in other words, think about running C++ on the JVM. Whoa, kind of weird. Okay. So LLVM, as I just referenced right now, is a low-level virtual machine project out of the University of Illinois, and compiler for a variety of languages and a whole lot of languages. I think LLVMs is always going to be important. So this is also a need to know. We titled this presentation here as need to know. LLVM is also a need to know, just like I think Graal is going to be need to know, at least for a short time before WebAssembly takes over everybody's lives. But WebAssembly is also going to be a need to know. So head on over to LLVM. Make sure you study up on that, because I think future is going to be all about LLVM as well. But lots of different languages you can compile for, and you can go to this project at LLVM. So LLVM, coming back over here to this slide, is used within Sulong, the layer that is able to make it possible for us to run our C, C++, Rust, and other languages as JVM code. Okay. So Truffle integration, this is for the dynamic typed languages, backwards compatible. Because of this, we could do things like profiling, debugging through the Chrome developer tools, language interoperability as well. Truffle is used at this particular address, and it uses an open source universal permissible license. I had a hard time getting that one out. Sulong, which makes the LLVM translation happen. It is an interpreter built atop the Truffle language layer and used to transform all these languages like C, C++, Fortran into that LLVM. Okay, so just like what Matt had asked previously about, and I don't know where Matt was coming from. I don't know the impetus for Matt's question about it. Wait a minute, is it free, or is it going to cost me something? I had the same thing, and I still have the same concerns, and that has to do with licensing. I think just because I think some people have a different perspective on Oracle licensing when it comes to Java. I certainly have my own interpretations, and it seems everybody has a little bit of an interpretation as to what new Oracle licenses mean. And Oracle has come out to say still Java is free. But I think for the most part, many of us have moved over to, say, like adopt OpenJDK or some of the others that are going to be free and open source. So I don't know how many here. You could tell me if many of put on the chat, please. I have made the move. If you have moved from a Oracle JDK to something like an OpenJDK, just so I can get a pretty good understanding of my audience here. But I think a lot of you are going to say, I have made the move for those concerns. Just, hey, what does this license mean? So I looked up the licenses at this particular moment. GraalVM is using an older GPL 2.0 for the licensing. Docker images are using a universal permissible license UPL, and LLVM has the UPI as well and has a license associated there. So far, everything is open source as far as the community edition goes, and you should be good to go. Is it in Docker? Absolutely. So the only thing that you would need to do is just say from in your Docker file, which is usually one or first two lines in your Docker file. So from Oracle /Graal CE latest, and you should be good to go. All right, look at that. I made the move. I made the move. All right, look at that. Okay. So yeah, a lot of people made the move. I love how I'm pretending this is an official poll. Looks like everybody made the move, so we should all do that. So excellent. I kind of suspected as much as well. So GraalVM installation, all you have to do is download it. That's one way to go about it. Untar it and build a path towards it. Okay, and it's as easy as that. Now, let me do a little quick screen share on here as well. There we go. Yeah, so I'm going to do a quick screen share here. All right. So if you were here for my last NFJS impromptu session, one of the things that I usually advocate as well is SDKman, SDKman.io. Now, I know for Windows users, it's kind of like a pain in the you-know-what, because SDKman, you have to go through some hoops just to get that installed. But for all Mac and Linux users, it's great because I get to do SDK list. So that's what I ended up doing here. And if I scroll right up over here, I already have this mapped and installed. I'm using the latest 20.1.0. So the only thing that I need to do in order to get this to work is, let's see, SDK use. Wrong way about it, Dan. Here we go. All I did here was just run SDK use, and this just transfers me over to Graal. No need to set up a path. Okay, so a hard recommendation for me to use SDKman, particularly if you have Linux and Mac. It's easy to set up and easy to use. Okay, so that's all I needed to do. Yeah, I was wondering about chocolaty. I don't have a Windows machine. I'm kind of ashamed to say that just because I should have all OSs being the good person that I am, but I don't. So I have no idea. If you want to write to me if somebody has Windows and chocolaty and see if you get SDKman through it, I'd appreciate the knowledge on that. All right. So yeah, and there it is. So we can use GraalVM, and within GraalVM we have all these different kinds of launchers. So here, let's take a look. Actually, I'll do a screen share again. Sorry, I don't mean to be jumping from screen share to slide all that often. But here, let's take a look. All right. So yeah, here's my screen share again. I'm already running Graal. So let's say I'm going to go to Java Home /bin, and let's take a look at what's in here. We have some new people under our house. Let's take a look. Graal Python, GU, which is the Graal updater. I'll show you that here momentarily. IRB, which is the interactive Ruby REPL. We have LLI for running LLVM images. We have native image. We have Node. We have NPM. We have JavaScript in here. And all these are now housed under Java. So you have a lot more tools to work with. Okay. So we have R in here. I have WebAssembly in here. Ruby versions, of course. I have R. I have gems for Ruby. So not only just the languages, but their tools as well is available. Now, one of the other things that I'm going to tell you about is this GU available, which is kind of like an apt-get or a brew, but specific to Graal. So let's take a look right over here. We have LLVM, native image, Python, R, Ruby, WebAssembly to interact with Graal. So all these are just the extensions. The only thing you need to do after this is do something like, let's see, GU install Python, for example. And I've already installed it, but it would just go through the process and install what you need. Okay, so that's using a GU install. Okay. Let's see, SDKman IO. Excellent, excellent. Thanks, Walt, for providing that. I should probably provide that within the slide. From SDKman IO, runs on any Unix-based platforms. Yeah, unfortunate on for our Windows friends on there. But for Windows, you do have an Ubuntu for Windows, or you have the Linux kernel on that. If anyone wants to give it a try, let me know on Twitter or email to see how you go about that. In the meantime, I'll try to buy a Windows machine so I could try that as well. Okay. Oh, thanks for saying that, SDKman. Not seen in chocolaty. Okay. I think over time, Microsoft is definitely open to more to open source. I mean, they own GitHub now, and hopefully we'll reach a point in the future where tools like that would be available to where chocolaty would be able to support things like SDKman. We'll see where we end up. Don't know, actually, on which version that is for the WSL, WSL2. So Graal updater, that's a good question. So yeah, okay, then I'm probably gonna heavily assume WSL. So I just showed you the Graal updater. Again, you have different components that you can download depending on whatever it is that you need. If your question is going to be, hey, can I run some of the Python machine learning? I tried some. I got pretty far, but I didn't get all the way through. So your experience may be different. So I could do something like gu install Python, and that would install your Python. So whatever it is that you need. As far as Java goes, what do you do with Java? You just do the same thing as before. Create a main method, Java, see it, Java. Nothing has changed. Okay. For JavaScript, this is going to be kind of interesting, right? I can run JS and then do like function and whatever kind of function you want with the return statement, whatever it is that you want with JavaScript, you can run JavaScript. And you could also run npm, so you can bring in certain libraries that you want. There's also npx, so you can execute any kind of JavaScript library that you want as well. Node on demand. So let's do a little screen share on here. Yeah, absolutely. Keep asking questions. It's perfectly fine. That's what this is about. I just want to show you a little bit about what's going on in the world of GraalVM. But let's go over here. I think I already have something already set up. Yeah, here it is. So I'll get rid of the --JVM here. So what I'm going to do, let me increase the font here. So what I'm going to do here is I'm going to run node really quick here before I do. Here's what the Hello World JS looks like. Okay, just a basic node application. But just to prove it to you, I'm going to do Java home /bin/node with this Hello World JS and be able to run that. And here it is. Here's a local host 8000. Okay. And here, let's take a look. I don't want to ruin that window. Let me do this one here. Localhost 8080 8000. There we go. All right, and there's our magnificent Hello World. What a great looking application that is. I'm running a node application using Java. Mind blown. Okay, so everything is integrated in one big tent. Okay. I think so. Yeah. Walt has an assumption. I'm going to join his assumption because it'll still be an assumption that this would work nicely with the JetBrains Suite, IntelliJ, PyCharm, because code is code, and it's going to interpret it as that. It's really going to be a matter based on how you use it. So I will join in that assumption very strongly. I installed GraalVM on SDKman on Ubuntu running WSL Windows 10 Home to write a Micronaut service so it works. Ooh. Thank you very much on that one. All right. Excellent, Gregory. Appreciate it. All right. So awesome. So we got our node, okay, and a bunch of other tools as well. So here's just an example of running node. Yeah, I did that $ Java home just to prove to you that what I'm really running is a Java-based node from this. So here's Kangek's GitHub to show JavaScript compatibility. And for some reason, I can't click on that link. Here, let me get this set up then. Yeah, this is a compatibility table that you see here. So let me come back and let's share my screen again, just to show you some of that compatibility when it comes to JavaScript. So let me do a screen share here. Okay, sharing the screen. Here it is. So hopefully you could see this okay. So what I have here is the compatibility levels of JavaScript. And somewhere on here, there it is. In fact, ooh, they have the latest version. Take a look right here at this column. These are the compatibility versions with the GraalVM, as opposed to some of the others, including Node, the original C-based and JavaScript-based Node. So here are all the different features on here. So it is a full-featured JavaScript. So nearly everything, yes, nearly everything complete, minus the proper tail call recursion, which has not been implemented yet, but some of the others don't have that fully implemented as well. So that's what you're getting from this, and I think it's pretty cool. Was it blurry? Was that website blurry, or what was blurry? Let me know. All right. So lots of great stuff that you get with Graal. Okay. You could get Python. You could get Ruby. Okay. Ooh, thanks, Gregory. Yeah, appreciate it. Oh, the screen share. Okay. Are the risk downsides switching from adopt OpenJDK to 20? Just switch to nervous about. So Steve Lopez, I'm going to say I don't think there should be any nervousness with JDK. It shouldn't be that even that hard to switch. I mean, at the most, I don't know if you're running Windows or Mac. If you're running like a Mac or Linux, then using SDKman, all I have to do is just SDK use Java, and then whichever version I need to switch to. And just like that, I could just try out different kinds of Java versions very quickly on here. So it should be easy. It should feel easy for you to change out a Java quickly and then jump back. So in other words, if you feel comfortable with your adopt OpenJDK and everything's working great, it should be very easy to switch to a Graal, maybe experiment with it, or maybe do something else, another project with that JDK, and switch back. In fact, you could have different terminal sessions all using different JDK. So it shouldn't be a nervous thing, and you should be able to switch very quickly. Yep. Yeah, Steve, give SDKman a try. I think you'll like that a lot. And one of the things that I do is, and I mentioned this on a previous kind of these sessions, is that if I'm stuck in a project that uses JDK 8 and JDK 8 doesn't have JShell, which is the REPL, one thing I like to do is just hop over to another terminal and switch something over to JDK 11, just so I could experiment with some things on JDK 11, but the compilation will be done in 8. Yep. All right. So as I stated here, lots of different Ruby, lots of different JavaScript commands are available. Let's take a look at some C code. And let's blow our minds. So let's come in over here. Yeah, sorry that was blurry. Hopefully the screen share isn't going to be quite that blurry. All right. So yeah, let me go out of this and let me clear the screen. Hopefully everything is a little bit clearer. I want to wait just like a couple of seconds in here. And here, let's take a look. Okay, hopefully it's a little bit clearer for you. So I have, let's go to C over here, and let's take a look at a Hello C. This one I took from the Graal website. It's a very simple one. So just a hello from GraalVM. Okay, and this is just C code that you're looking at here. Okay, that's all it is. So what I'm going to do is I'm going to run C lang. And here it is. This is the call I'm going to make. clang-c -01 emit LLVM. And so when I run this, what I'm going to get out of this is, here, let me do it again, is I'm going to get a BC. Notice the BC in here? That's what happens after I did the compile. This is a bytecode. And so what I could do after this is I could do LLI with that hello BC. And what we'd end up looking at here would be the running of this application using LLVM, which in turn is going to be using the JVM. Okay, so let's come in over here and let's do CPP, for example. I have an app here for calculating the factorial. Let's take a look at what this looks like. So here it is for calculating a factorial. Okay, all C++ code. Now, this one I'm going to do a different command called clang ++01 -c emit LLVM. Include the standard library for C++. And my output, my -o, will be factorial BC, which is the bytecode. And here's the source code factorial CPP. Okay. So now that I have this, I could run factorial BC. And in fact, I would even say that this looks very much like the way that you do Java, except this is just going to be C++ code. So here it is. I'll enter the, it's going to be, let's do something a little bit more sensible for a factorial. There we go. So 5 with a factorial on that would be 120. Okay. So yeah, we could compile C, we could compile C++ along with it. Let's see some questions here. What is the current future relationship between adopt and Graal? I think just separate projects. I think they're running on their own. One is outside of Oracle, one is inside of Oracle. Adopt OpenJDK is just providing a JDK for you. So just different projects, and I think just run by different people. I don't think they're interacting essentially, but just separate projects. Okay. I can't answer. So Scott, I can't answer your question. I'm under the same concern there, and I think it's a valid concern. So I'm not sure I could really answer that question. The question was, why should we assume that Oracle won't do a GraalVM what they did for Java? And maybe I have a different interpretation as to what's happening with Java. I don't know if they're putting their best foot forward or not, because they did introduce that licensing, and then it seemed very quickly they were like, no, Oracle is still free, but, and so yeah, that I think that but had a lot of people concerned about the licensing and what it means. I can't answer that, Scott. I have no idea what will happen in the future for that. Okay. Yes, you could link C and C++ together. You could, and I'll show you an example where you can call something from, say, like a C language or a C++ language. Yep. Go, maybe. If LLVM supports Go, then I would say yes, but I've never tried it myself. What problems would you solve with GraalVM? I was going to address this later, but that's fine. Let's answer the question now. You have an application that was developed by somebody else in a different language, and instead of rewriting it within Java or the JVM, you just bring it in. It's just one big happy family within the JVM. So in other words, someone created something using Fortran. Take that Fortran code, compile it with LLVM, turn it into a bytecode, and then run that bytecode within one application. Behind the covers, it just, or outside of the covers, it just looks like one grand big Java application, but behind the scenes, there are different parts to it. I would say that's going to be one of the biggest wow factors for doing that. Okay. Or other languages, right? I mean, this thing supports multiple languages. Yep. So on this slide deck, which I think is downloadable for you, you can take a look at the resources here. You can download those as well. I kind of just went through this for demonstrations. It's probably easier to demonstrate than showing through slides. One other thing, just like you saw in the previous example, we were linking in the standard library, but you could also link in shared objects as well. So for curses for like a terminal type application, I could just bring in the SO for that. When will Graal, you know what, I'll look that up. I don't know what the answer is. When will Graal support COBOL? Maybe it does already. I have no idea. I'd probably take a look at the LLVM to see if COBOL is even part of it. But I don't know whether to take that statement as a joke or serious or not. I think probably a little bit of column A and a little bit of column B. Yeah, that's right. I knew you were going to say both there, just because we see during this virus right now that a lot of states, due to a lot of high unemployment numbers, a lot of systems are going down, and a lot of these unemployment systems were running COBOL. So yes, so COBOL would certainly run some of the world problems along the way. Yep. Other key technology is special language interpreter. Yeah, there's COBOL. Hey, nice. Great. Thanks. Yep, absolutely. All right. So yeah, take a look at Jason Bolt's statement there. Has that available. Okay. All right. So behind the scenes, we're using a few things: JVM CI, JIT, hotspot, JIT. A lot of acronyms on there. So JVM CI allows us to swap in a different compiler, and allows us to swap in this new compiler that is written in Java, particularly for the C2 server compiler. One of the problems with the C2 server compiler is that it was getting old and tough to maintain, and not a lot of people knew how to work with that. So one of the things they're experimenting with is the ability to swap in a different kind of compiler and swap in what to do during hotspot. And that's part of that experiment is what makes GraalVM work. Okay. So hotspot, core component of Java SE platform. It does run the JVM specification, delivered as a shared library. It's a bytecode execution engine and includes dynamic compilers that compile at runtime. And one of the more popular ones is this just-in-time compiler, and that is when only compiles code actually when it's in use and hotspotted. So what this means is that certain code gets used over and over again, and this is why JVMs need to be warmed up at times, just because the most often used classes will get optimized over time. Okay, and that's the just-in-time compiler. And again, this is why benchmarks need to be warmed just to get that kind of optimization out of the way. Now, we'll talk about native image. One of the cool things about native image is that this you can compile these applications to be native. So that also means that things don't need to be warmed up. This is particularly nice for people who are creating microservices in that where they can't stand that warm-up time. So we'll show you native compilation here in a bit. All right. Let's see, questions on here. Are there cheat sheets for using GraalVM that you recommend? Command line options, various optimizations. No, not that I know of, particularly on the optimizations. They got a lot of switches, so you'll be finding yourself doing a lot of -H's, things like that for that kind of stuff. I'm not sure there's a cheat sheet around. If we do find one, or if you do find one, ping me and see if there's anything on there. I think the GraalVM website has a chart, but I probably wouldn't call it a cheat sheet. Any performance trade-offs for running JVM languages in JVM using Graal over running them natively? I don't think so. I haven't officially done any kind of benchmarks with that. I think they are the same. They're just using a different compiler underneath. So the compiling doesn't have anything to do with the runtime. So it's a good question. I don't know, and I haven't seen any benchmarks on that. Yeah, so when I say faster on this, I'm just saying that the server compilation is swapped out. Whether that compilation ends up faster, I believe it is fast. Now, one of the things the reason I say faster is because one of the concerns would be, hey, why is the compiler Java? And still one of the things that people think about when they think about the word Java is that, Java's slow, which I don't agree with. And Java has proven even for many years, even past the year 2000, that Java can hold speed very well. And so one of the reasons why I included faster on here, or at least just as fast as the C++ counterpart, is that Java does a good job at making sure that processes run fast. And so that's what I mean by that. Are there reflection issues using GraalVM? Not if you're just running Java. So if you're doing a Java-C Java, just like that, there shouldn't be any issues with that. Now, the reflection issues are going to come in when you want to do native imaging, because a lot of that reflection is tough to do at compile time. So you may find out that when you do a native image, something might fail just because reflection-wise, something cannot be found, a particular class can't be found, or something else can't be found. So that may be a little bit of a trial and an error. So I'll put that question of like, no, everything should be fine with the exception of when you do a native image. Okay. So this slide right over here, the C2 compiler is the thing that provides the performance, that provides the speed. Problem is, and I looked through many blogs as to like how they are getting this to work, and using Java as a compiler, which is something that hadn't been done before. This is what it is. They are swapping away that C2, that server-based compiler, because the old one was C++ based. It was getting older, and it was a complex base for others to use and maintain. Okay. All right. So tiered compilation, Java-C starts its execution in interpreted mode. JVM tracks each frequently called method, compiles them using C1, and then the part that gets swapped out with the C2 hotspot monitors future calls and methods and optimizes them with the C2. That's called the tiered compilation. So just as stated before, this C2 is now written in Java, and that's what brings that speed over to GraalVM. Now, Polyglot. So here's one of the reasons why you might be interested in Graal, and for you to take a look at it and why it's a need to know. First three here are from the website. The fourth one is mine. Library is not available in my language. I need to rewrite it. Take a look at Graal. Again, every time you have this situation where at work you have a Python programmer, Fortran programmer, C++ app that you need to integrate with, and you don't feel like using JNI, Java Native Interface, there are other ways around it. Experiment with GraalVM. That may be something that what may make your life a lot easier. That language may not be, that language would be a perfect fit for my problem that I'm trying to solve, but we cannot run it in our environment. That problem's already solved, and we've been using it for many years, but the language is too slow. We want to hire some talent for machine learning is my idea here. So R is great for machine learning. Python is great for machine learning. Things are already developed in those languages. So why not bring those in? Okay. As a solution, there are a lot of other solutions as well. You could use GraalVM. You could use, like if you're doing TensorFlow, you could do TensorFlow serving, which exposes RESTful APIs so that you can submit information to it and have a machine learning model expel some information out of it. Let's see. So does GraalVM kill Jython? Let me be a good. I'm going to be a good person here. I had a snarky one about. I think Jython killed Jython, but that's not my official answer. I'll just make a little slight joke there. But I don't know. I hope the best for Jython, because I hope the best for JRuby. JRuby is going strong. I know that the people of JRuby are looking at Graal and doing comparisons, so they're embracing this new technology. I don't know to what extent though, but these alternate Jython, JRubies, I think are there to stay. Certainly JRuby has put a lot of effort into it and has a very active team going on right now. I don't know about Jython. I think Jython had been abandoned and probably been picked up recently. I don't know where Jython stands itself. All right. So polyglot languages, again, we can do various things. We could go from Jython to R, LLVM to JavaScript to R to Ruby, whatever combination it is that you would like. Okay. And I could run in polyglot mode. So from that Java, I can call C++. And from C++, I could call something in Java or something in R, something in JavaScript can call other languages. That's what the great part about this polyglot is. Okay, and we use something called a polyglot interoperability protocol in order to do that. Okay, so it's kind of like an internal ring and an internal protocol in which one language can interact with another language. Okay, so one of the really cool features is this, which I think is kind of cool right now. I can't find it particularly all that useful, but let's take a look. So this one's the Polyglot REPL. So I'm going to do Polyglot JVM shell. Here, let's take a look at the screen on that one. So here I am. Let me do shell, and here it is, Polyglot JVM shell. I think it's cool. I think it has a lot of potential. I'm not sure it's there yet, but notice the languages that are here. I have JavaScript, and so therefore this is a JavaScript REPL that's going on right now. I'm going to do a Control L on here. It's going to take some time to switch on this, but once I do so, this is going to end up in Python. Maybe. And notice how slow it is. So eventually this is going to get to Python. I just did a Control L. But, oh, there we go. there it is. So here's Python. Let me do a Control L again. Oh, look at that. Kablooey. Looks like something's wrong with the R. But I should be able to do Control L and switch between all these languages. Now, one of the things about this, and let me just bring this part up. So Control L will allow me to switch through all these: JavaScript, Python, R, and Ruby. But one of the things that is missing here, I think there's a lot of potential to include JShell. I think there's a lot to include a Groovy shell. See, I love you, Groovius. Scala, Clojure. I think having all these shells included with this would be outstanding. And if I am doing, say, like JavaScript here, and if I do const b, which is now 20, and then I switch over to, say, like Python, I would love, I don't know if this is useful, but I think it would be really, really cool. Oh, no, it's going to take forever. But I think it would be really, really cool to do like a print open paren d. D, something that I bound in JavaScript to make use inside of Python, I think would be pretty extraordinary. Like, how much would it be cool to do this? But it says D is not defined, even though I bounded it, or I binded it. I don't know, what's a verb on that? I bound it to JavaScript. I think that would be really cool in order to do something like that. So a lot of potential there. Now, without further ado, since already running out of time, so let me come in here. Yeah, Walt, I don't think so. It would be great to share those with one another. I don't know, because that came out really new, and I haven't prepared for that, Ibrahim. So not quite sure just yet how WASM would integrate with this. So I'm at a loss right now, because that is just very, very recent when that came out. Yes, everything passed by value, just because I think JVM rules on that one are going to be passed by value. Let's see. So let me head over to the slide deck over here. Let's see. So coming in over here, one of the things that here, I'll just skip to the good part here. Maybe not. Roman asked me the question, and I think people may have different opinions on this, recommending using GraalVM over adopt OpenJDK if you don't need the polyglot feature. I mean, it is behind the scenes a JDK version 11 already. And I think in the end, if you're evaluating, perhaps do some benchmarks of your application and notice to see if there's any difference with Graal. And if there is, try it and use it. I don't think there's going to be that much difference, to be honest with you. But again, metrics will rule that, and you'll get an answer from that. All right. So what I want to do is I want to talk about native. So using native image, we can compile to something that resembles a native execution, like where you do a dot slash and then it just looks like some kind of native program that you wrote with C or C++. This one, though, does not run on a hotspot VM. There's another VM called a substrate VM, which will interpret that code. Faster startup time, lower runtime memory, and this is the selling point for Graal. This is the thing that has been pushed extensively by a lot of these new microservice frameworks, including Quarkus, new book out by, here we go. I don't know if you can see this here, Alex Soto Bueno and Jason Porter. I'm just telling you there's a new book out. The reason I know is because I reviewed this whole book, 340 pages in 1 week. You ever review a book, 340 pages in 1 week? It's exhausting. Some guy, Michael Carducci. Anyway, on the chat, he's saying Micronaut. Yeah, I was going to get to Micronaut. Yeah, so 2 microservice frameworks that are out right now that are really vying for this using native compilation because of the speed. Remember, there's no warm-up time for this. So deploying this on Kubernetes is awesome because lower memory footprint, no warm-up time, and you just get going. Okay, so take a look at those 2. I'm going to tell you equally. I just happen to have a book for Quark. I don't have a book for Micronaut because Michael Carducci didn't buy one for me. If he did, I would have showed it to you. Okay, so take a look at those microservice frameworks. You'll love either one of them. I think if you liked, and so to Michael's point here, I think if you liked Grails, if you enjoyed Grails a lot, I think you're going to enjoy Micronaut a lot. I should be enjoying Micronaut a lot because Micronaut is a toy from the 1970s, and a Micronaut is something that I had. It happened to be one of my favorite toys in the entire world. Okay, that was before Star Wars came along. All right, so let's talk about native compilation. Okay. So native language support, pre-compilation ahead of time compilation, Java, Scala, Clojure, Kotlin, without pre-compilation, executing via JVM languages, Ruby, Python, and R. But let's take a look to see how to get this going. It is kind of a pain at first. So a few things that you need to load first is glibc, zlib, or zlib-devel, zlib, and gcc within your Linux and Mac OS. Or if you want to get Cygwin, you can ensure that these libraries are there as well. But once you have this, then you could go full-on native compilation, okay? So here are the limitations. So someone was asking about reflection. A few other things is that compiler needs to know of all classes and all bytecode that will run at runtime. It's not something that will be discovered once you start running it. Use class reflection requires accumulating metadata for these elements. So for whoever had asked that reflection, if you're not doing native compilation, everything should just work straightforward as you expect. But once you do native compilation, certain things have to be known before you can continue. So use a static analysis, intercepts calls like class for name, which you may have, including if you're doing any kind of database calls, right? Usually put that driver under class name and targets elements embedded in the code. All right. So native image is this. Run native-image and native-image with a jar as a jar file, and that will create for you an application. So let's take a look at this as a little demo. Here we go. All right. Let's see. So let me do, I'm going to do Scala. So I love Scala. I think everybody should do Scala. Oh, AOP. AOT, ahead of time compilation. All right. I think Scala is the greatest language in the world. I love it so much. I wish I could marry it. But it is one of my favorite languages. So I wrote this and quite a while ago. And here it is, cat, source, and prime. Okay, and here it is, object prime. Okay, so it's just going to calculate a prime number on here. And so what I'm going to do is I'm going to run these commands in here. One is, what does the regular Scala look like? And then what does the ahead of time compilation do? Now, you can do this with a regular Java application. I'm just doing this with Scala. So let's take a look. All right. Well, I have a nice little handy script here. And what I may do is I just may do it in like little parts. So let me do this here. I'm going to run this one. Here we go. So I'm going to compile my prime.scala. And here we go. There we go. All right, so that's been compiled. Now I'm going to take a time for this here. Here we go. Here's the time for it. Not too bad, but this took a total here of 2.41 seconds. Okay, let me do that again. Maybe kind of hard to see with the share screen here. Got a little bit faster here at 2.3 seconds. It didn't seem that long, but I guess it was 2.3 seconds. So let's come in over here, and what I'm going to do is I'm going to run native image in here. Now, here just happens to be one of those switches. Let me just do this one here. That -H just happens to be one of the switches that we use with GraalVM. Okay. Now, this one here, what we're going to be doing is we're going to be building a Scala image in here. And this is going to take a while. Okay. So it's just one of those things that you'll have to wait for, particularly with a native image. And so while this is cooking, so here we can see here that prime is cooking right now. It's taking a while. Let's come back to this. I'm going to pretend this is a cooking show. And in the meantime, I'm going to bring my friend Michael Carducci in here. Carducci, are you in? You said you had something to show us?
Can you hear me? Maybe. Can you hear me? Maybe not.
Oh, excellent. Thanks, Zachary. Yeah, so Zachary has, if you're interested in Micronaut as a microservice framework, because you love Grails, you love everything about it, same people developed this, there is the guides Micronaut that Zachary had provided for us. All right.
All right. Any audio?
Nice. Nice. Yeah, you got it.
It's
fantastic shirt too. I think the audience is right. Yep.
Thank you, Daniel. So just while we're here, while we're waiting, let's try something.
Yeah.
I realize, by the way, how difficult it's going to be to pick a card over a webinar. So we're going to do something a little different. I'm gonna kind of go through the cards. I want you to see one in there, not this one. Let me move this here.
Who, me or somebody else?
Whoever, anybody who's watching. In fact, let me move this right over here. That'll give everybody a clearer picture.
All right.
So I want you to see one of the cards in here, not this one. That one's going to be a little too easy to guess, a little too obvious. But I'm just going to come up to the camera and come just like that. I don't know if you saw one in there. Let me go one more time. Watch closely. Did you get one? Just say in the chat. Don't say what it was. Just tell me yes or no. Did you like see a card in there? You've got one in your mind. Okay.
Do that again. Can you do that again or no?
I think as long as a couple people have got cards. Oh yeah, see a bunch of people have got cards.
Okay. Right. Okay, I do too. Okay, cool.
All right. Well, we're gonna not use the 7 then because you just told me what it was. So here's what we'll do instead. I'm gonna pull one out of the deck and show it to the camera here. This is probably not your card, right? This is not your card. Somebody give me a no or a yes.
No, not mine.
Okay, we got some this. All right, watch this card right here. Ready? 1, 2, 3.
Yeah, that was the one I chose.
Oh, right on. We got some yays.
Wow, look at that. We got
and then let's try this. I'm going to stand up so you can see this a little better. There we go. And it's gone.
Wow.
Dano.
Yeah, what? That's amazing.
Look
Good job.
Under your laptop.
What?
Lift up your look underneath your laptop.
What the hell? What? How'd you even put this in here?
Show it to them.
Are you serious? The hell, man? How did you get in my house?
Just a little trip down to
That's
the
amazing,
ABQ.
dude. What?
Little road trip. I've been cooped up too long. A little bit of B&E. I love it.
Oh man, what? Oh, man, I'm freaked out. I feel like those dudes over on YouTube. I don't know if you've seen that video with the who's that magician? The fake David Blaine. Oh my gosh! If any of you have not, I feel like what the f? What the f? David Blaine, this is devil work. David Blaine.
Now I just need to send you the rest of these.
Cheez-Its.
Cheez-Its, yeah. So now I just need to send you the rest of these.
That's amazing.
All right, man. Let's check back on our program.
Yeah, our application. Yeah, so here it is. So let me.
You got to share your screen again.
Yeah, I'm just freaked out as all. How'd you put that card in there?
It's a sign of a misspent youth. Native compilation. That's how I did it.
That's right. Native compilation. Oh man. All right. So yeah, here we are sharing screen. That process that I ran from using this native compilation, I'm going to put a time here. What this created was this like little prime executable, and it just looks like an executable. And so if I just do .prime from this, and let's do a time on it. Remember, what was the time, like 2 seconds or something like that? I'm going to do this, and we're like at 0.01 seconds. So this runs just like we were just running natively. Now think about this, and this is the reason why these new microservice frameworks like Quarkus, Quarkus, and Micronaut are vying for your attention, just because Graal is very powerful for doing up your microservices and deploying them. And not only that, they have helpers. And Michael, you could probably tell me this, since you do a lot of Micronaut. Does it have like ability to create Docker images just as part of the framework itself?
Target a native Docker image.
Yeah, come on in. I always want you here, Michael. I don't know why you always leave me crying in solitude.
And I think Zach is probably typing to add some content there too. But yes,
okay,
yeah. So you can deploy natively.
I know who Zachary is. Yeah, okay. Zach knows all. Absolutely.
Yeah.
Okay.
Zach knows more than I do.
No, but yeah. So. And I guess Zach's going to be typing out, but what do you know as well about Micronaut and ability to create Docker images that are based on these Graal native images? Or should I wait for Zach? Come on, Zach.
Yeah, Zach's got more.
That's amazing.
Actually, I think
I'm so freaked out.
Now I'm short a card, but I've never played with a full deck.
There we go. All right. So I think Zach's going to know a lot about Micronaut on there. Okay. Yep. And Lucas, let's see, Lucas Rasson or Racon, hopefully I pronounced that right, says we are running Micronaut with Java. It's not my expertise, but I know Micronaut is definitely huge, particularly amongst Groovy and Grails programmers in the past. Yep.
And Kotlin.
So native image is where it's at. Yeah, go ahead, Michael.
Oh no, I was just saying, and Kotlin is the other one that I think the other language right now with first class support in Micronaut.
Wow. Okay. Yeah, don't do Kotlin. Use Scala. No, I'm just kidding. No, Kotlin is great. Do that as well. All right. So Zach Klein says default Micronaut CLI project includes a Docker file and a script to create an image out of the box. And I suspected so because Quarkus has that as well. So Quarkus and Micronaut are the competitors in that case. So we have that. I suspected Micronaut did have that. We test the GraalVM support regularly as well. So it's a first-class platform, Micronaut. And that's going to be the key thing. So I know a lot of you are Spring Boot programmers as well. One of the things that Spring Boot is trying to catch up on is this, the native compilation, creating images, and uploading quickly as a first-class support onto Kubernetes. That's where it's at. So this is why we created this presentation. This is why Michael said, hey, let's do this presentation here, because this is also a need to know. You have to know about Graal, particularly for the native image. Someone was asking, why do I need to do this? That's going to be the reason. That's going to be the really huge reason why you would need to do this.
And you actually touched on a few things here that I want to bring up. You mentioned WebAssembly and why that's going to be,
nice.
I've had nothing else to do during the quarantine but come up with new tricks, and then nobody to show them to. So, but yeah. So I know there are a few things I want to call folks' attention to. The first is the No Fluff workshop series. These are basically imagine this format, but a lot more interactive, a lot more hands-on, a lot longer to really dive into some of this content. Dano, I know you're doing a training on GraalVM. You're also doing some at the upcoming No Fluff Just Stuff virtual conferences. Both of these are on nofluffjuststuff.com. But if you want to drop into a handful of workshops, it's definitely worth doing. But the team subscription option is really the best way to go. And if you go to nofluffjuststuff.com, there's already a ton of stuff on the schedule. I know we've got Rust and WebAssembly. I know we've got GraalVM. I think we just did a workshop, a full day deep dive on LLVM. And we're probably going to run that again here in the coming weeks. So there's an opportunity to really dive in and get hands-on with all of these. Definitely worth checking out.
Yeah, I got a point to that, and I'm glad you mentioned that, because I wanted to mention this. Not that there's any competition for this, or what we believe, or who's going to be the best Nostradamus in saying what's going to be prevalent. Brian Sletton thinks right away that WebAssembly is going to conquer all, and including with
good
LLVM.
reason. I mean, his argument is sound.
Yeah, his argument is sound. My take on it is I agree with him. I'm not sure it's going to happen that fast. So I think the velocity is the question here. I think GraalVM is going to be definitely useful. I would probably argue short term, because again, I think Brian Sletton's going to be right. Brian Sletton's usually right, inevitably. Sounds like an insult. No, but he's going. I think he's right. I think WebAssembly is going to win out to the point where Graal may not be quite as useful, just because we're just going to be developing on our own applications in whatever language that we want, and we're just going to deploy onto the web. Ta-da, that's it, and there we go. I don't know how fast this would be, so my argument would be I think GraalVM is going to be something that we would need to use as Java programmers right now in order to do the native image compilation and deploy that. But in the future, that may not be the case.
Right on. And then I see some other things in here. And actually, that's a really interesting question that I want to say Lucas brought up, asking about how well Groovy works as a native image, because often there's so much metaprogramming and stuff happening in Groovy. So that I'm actually kind of curious about that as well.
Yeah, I'm Scala mostly. We kind of have the same thing because we have a lot of metaprogramming, but our metaprogramming is really just the decorator pattern. It's how we do the metaprogramming. It's kind of like the way C# does extensions. It's just the decorator pattern to change things. And so at compiler time, I don't know. I suspect Groovy's the same way, because it's the compiler that's just going to create JVM code.
Yeah, and I think that's a big part of it. Well, I mean, Groovy still does runtime metaprogramming, but I know Micronaut tries to shift all of that, or as much as possible, into compile time. So with the decorators and things like that in Groovy, the Micronaut compiler will just do all the AST transforms and things at compile time. And so presumably it will try to do the other metaprogramming type stuff as well.
Yeah. Zach said, for what it's worth, Micronaut isn't relying on Groovy in any way. However, you can use pure Java or Kotlin as well. And Lucas had a agent lib native image config on there. I think for helping with that. And let's see, does it ever happen that fast working in enterprise running? Is that Java 6?
Yeah.
I can't answer questions.
Well, that was just a commentary on, does anything move that fast?
Yeah. Oh, I see. Okay. Yeah, understood.
Yeah.
Not familiar with JavaLin.
I'm not
heard
either.
of that project. Yeah. What is JavaLin? Here, let's take a quick look here. I know we're running out of time, but you had something, Michael?
No. That was it. I'm just kind of going through this with you, and I'm making the usual announcements.
Yeah, I love learning from the audience as well. JavaLin is a Java and Kotlin kind of framework. That looks really cool because it just looks very, very, very thin. Not a lot to it, which I like simplicity as well, that you can write. This kind of reminds me of Sinatra and Ruby, to where you can just create web services on the fly. I'm just taking a look at the documentation here. And so I don't know, but I think it'd be worthwhile to find out, hey, can I do a native installation using JavaLin? I think that'd be awesome.
Yeah. Well, all cool stuff. I know we are about out of time. Dano, a couple other questions that have come in the chat. The one was the recording of this. Yeah, this is going to be, this will be available on nofluffjuststuff.com. It should be within 24 hours. I think there's like a nightly task that goes and pulls these in and does whatever it needs to do. Oh, wow. But I'll double check on that here over the weekend and see what happens. The other was
someone gave us a kiss. Thank you very much. Appreciate it.
The other thing was, Gary, I don't know if the workshop subscription will pull in a ticket for the tour shows. I'd have to ask Jay about that and see what he's thinking in that regard. But I do know for folks who register for ArcConf, there's an option to get a very cheap workshop subscription as an add-on. And I think they're doing some promotion right now. If you register for ArcConf before soon, you get like a free Apple Watch or a Samsung Watch or something, which sounds cool.
Yep. Cool.
Even though
by the way, I've got a Scala deep dive. So if you want to ditch that Kotlin and come over to the language that inspired Kotlin, where it all started, Scala full day coming up on NFJS. I'm just saying.
All of these are on nofluffjuststuff.com. But I know we're over time, and I want to be respectful of folks, and they're also probably starting to drop off because of other commitments. So, Dano, I want to leave you with the last word.
Last word is take care. We care about you, not only as customers, but as human beings as well. Dangerous time right now, so definitely take all your precautions and stay healthy.
And that was supposed to be the last word, but I'm also Gary. Yes, if you register for ArcConf, you'll get this year and next year, because I know the full intention that No Fluff is to do everything that we can reasonably do so live next year, but that's kind of a nice little bonus. So all right, I'll let you do your last word one more time. Thank you, folks. Over to Dano.
Yep. Karen has be excellent to one another. Let's do the Bill and Ted thing. All right. Thanks, everybody. Appreciate it. Party on, dude.